It's a pleasure to introduce the hydro-cooling server hashboard repair. As the picture shown, this is the general look of the hydro server. In the server frame, cold cooling water enters from the top joint to cooling plate of power supply unit. In the cooling plate goes through a loop and come out from the next joint, going through this plastic tube. Then feed to the cooling plate of the hashboard. It goes through a loop inside. Send out the hot water from the joint. Such is the flow circulation of the waterway. The inside top half of the server is the power supply. The bottom half is the upper and lower two hashboards. In the middle of the two hashboards is the hydro cooling plate. The whole structure is physically upper and lower two hashboards, but on a hashboard is logically divided into two slots. The below hashboard is divided to slot 0 and slot 1. The top hashboard is divided into slot 2 and slot 3. When you need to analyze minor logs, slot 0, slot 1 as shown in the picture. Slot 2, slot 3. This is where it corresponds. As shown, this is the entire hashboard that has been removed. The bottom power plate is 0 and 1. The top ones are 2 and 3. When we need to remove the top cover plate, we just need to remove 4 spring screws. After removing these 4 spring screws, we can see directly the hashboard. After removing the hashboard from the chassis, remove top cover, as shown. The whole hashboard is physically one board, but logic says it's made up of 2 slots. We can assume the middle position separates it to 2 slots. Above is a slot. Below is belonging to another slot. The top is slot 2. And below is slot 3. We test the hashboard. Test fixture control board. You can use the control board that comes with the machine. This is the power supply. There are 2 slots on it. The top slot is 2, 3. Below slot is 0, 1. When we test the hashboard, we can use either slot for testing. We just need to burn the test firmware into the control board. It's ready for testing. Test program. It's the same mop stem used for air cooling miners. Test command is ft redshift. We also need to run a power on command and rst set 1.8 volt and set 0 volt command. When the test fixture cable is plugged to slot 0 and 1, we use these two RST set commands. Set RST to 1.8 or 0 volt. When the test cable is plugged into slots 2 and 3, we use the following two commands. Test the hashboard need 40, 2 volt DC. This is the power supply. Provide voltage to hashboard. We need to set the test voltage to 42 volts. The following is the test fixture. Control board's connection. This is a 1-2 volt power supply. A network cable connected the control board to your computer. The computer keeps the same setting as air cooling test environment. This makes the settings exactly the same. Test cable of control board. The I/O interface of the hashboard is connected. Above plate is the positive terminal of the power supply. Below is the negative terminal of the power supply. When we prepare the connection for connecting test cable to hashboard or connect power supply cable to hashboard, connect power cable, we need to keep it power off. Then connect. If turn on the power first and connect the cable, or maybe burn out the parts on the control board or hashboard. Because 42 volts supply voltage is high, current is big, so we need to connect when the power is off first. Second to power on. We've connected the control board and the power supply cable to hashboard. Then we begin to test. In the Mockstorm test program, to test board, let's copy and paste the FT redshift to the command row. Power on the power supply. Press enter to execute. This is the test has been finished. Let's look at the test results. From the test beginning, here we'll show the miner type. Number of chips per slot. The serial number of the hashboard. The chip bin information. In this load platform CFG position, some DPO settings can be seen, such like DPO power on is 35 liu. Reset. DPO is 197. Now the control board test cable. It's connected to the slot 0, 1. So the test results display as shown on screen. The test result display is slot 0 and slot 1. If the test cable is inserted in slot 2 and 3, the test results also will show slot 2 and slot 3. And now slot 0 test result is pass. Road push also pass. The final result is pass. If there is a problem at either slot, the result will show the slot is failed. This is about the FT redshift test. Next, there's the reset command and the power on command. Why do it need a power on command? Because on the Hydro Hashboard, the front 8 domain, the LDO power supply is provided from the control board. In this location, there is a test point. This is free from the control panel. When only execute power on command or execute FT redshift, the control board will output a 3 to this capacitor. From this capacitor sent to the front, Bake loop of LDOS. The top and bottom together up to Bake loop of LDOS. As the power supply of LDO, if command are not executed, this position have no voltage. So the first state group, LDOS has no input voltage. We can take some measurements. Voltage at the capacitor. Only 0.5 at this time. Because we're not executing power on command, so there's not enough voltage. Next, we execute the power on instruction. Copy and paste. Execute instructions. Next, we measure again. The voltage at this circuit point. There is a voltage of over 3 volts now. So the front 8克 groups LDO have enough input voltage already. We measure the first domain's LDO. Input voltage is higher than 3 volts. The output is 1.8 volts. After executing power on instruction, then we can run reset setting instruction. Set to the 1.8 VTV or 0. This instruction we can use to set high voltage 1.8 VTV. Copy and paste to execute. After execution, a green LED will indicate reset for high voltage 1.8 VTV. Lights on indicates that the reset signal is 1.8 volts high voltage. Then we execute. Set reset signal to 0 of low voltage. The LED will go out after the execution. The LED is extinguished after echo 0 executed. LED indicates reset is set on or off. So we can use these two instructions to help with RST signal repair. The RST failed defective hashboard. If you want to execute the RST instruction, we have to at first execute the power on instruction. So when we start to check the hashboard, when need detecting the signals, we usually execute this power on instruction first. Make the entire hashboard LDO power supply normal. Then do the signal detection. The power supply of the hashboard is shown in the figure. This position is the positive pole of the hashboard. Below this is the negative terminal of the hashboard. 42 volts DC provided by the two poles. This is the first domain of the hashboard. This is first chip. Next is the second group chips. Within a domain, the two chips power supply provided in parallel. From first domain chips and second domain chips, all the domain backwards, each domain is connected in series one by one. This is keep the same construction as air cooling hashboard. intergroup chips parallel connection, group-to-group in-series connection, from the head to the tail. This is the first group, and then the second. Series connect. Domain 3 to domain 4. Until to the end. All the chips power supplied by domain connect in series. In the actual board, this is the positive terminal. This is the negative pole. And then here's the first chip in first group. And then here's the second chips group. All the way in series. To the end of chip group row. Then a second row of chips followed. The conductive copper sheets connect next chip domain row continue in series. The voltage keep series passes on to back. Pass on till here, then pass. The left copper sheets continues to backwards. Until here go through conductive sheets. Delivery all the way backwards. So power supply goes from beginning until the end. The series structure is the from beginning to end. All the domain on the board is connected in series. Form the power supply loop. For a hashboard, except the series connection domain voltage. In addition, need the LDO voltage to keep the signals transmit normally. The LDO provide output voltage to the chips. Each domain there is LDO support. Some hashboard only have one LDO, some hashboards have two LDOs. As shown. This is the case with two LDOs provide voltage to chips. Up 1 and up 2. Always. Up 1. Output 1.8 volt. As the input of 1 LDO. The connection relationship between up 1 and up 2 is shown in the figure up. The voltage of the pin 5 output supplied to the first and third pin of the up 2 as the third LDO input. At the same time directly input to the chip. provide the 1.8 VTV power supply for chips. The second LDO output 0, bar volt. Directly input to chips. So the first LDO as the 1.8 volt power supply of chips, also as input of the second LDO power supply. The first LDO up 1. Pin 1 and pin 3 connect together as input. Connect to the left circuit wire as shown. Connected to a 4.7 ohm resistor pad. The other pad of 4.7 ohm resistor. Connect to this copper sheet at the left side of this domain. That means connect to the positive pole of this domain. Therefore, input of the LDO of first domain. Input power for the first LDO is from the positive pole of this chip's domain. Input to the first LDO by going through the 4.7 ohm resistor. Behind all the LDO is power supply. All are the same structure. In all domain, LDO power supply are all the same principle as described above. But on the hydro minor hashboard, the front 8 or 9 domain, the power supply of the LDOS is from the control board. This is the difference between hydro cooling and air cooling board. So we need a power on command to provide power to the front by LDOS. If the power on command not executed, this front LDOS have no power. So the signals across the board won't work. 301. Before measure signals. At first execute the power on instruction. Make the entire board LDOS have a normal power supply voltage, then start to measure other voltage. Or do other signals measurement. Our current LDO with the 1968 chip is 1.8 VTV and 0, bar-V output. Crystal oscillator is also 1.8 volts supply. If the chips type on the hashboard is 1973 or 1978, our LDOS output are 1, 2 and 0, C5F. The crystal oscillator is also 1, 2 power. TH signal on the hashboard. The hydro cooling hashboard is the same as the air cooling hashboard. Also transmitted are these 4 signals. The reset, the CLK, RXD and TXD. The direction of the signal is shown in the diagram. Reset coming in from I/O port. Send to the first chip. Then transmit as a snake walk from domain to domain, all the way from the first chip. Pass to the end chip of the top half hashboard here. Then out from the last chip of the top half board. Wire through the side area. Send to the first chip of the bottom half of the hashboard. Follow the serpentine walk after entering, all the way to the last chip of the bottom. Then out from the last chip to the two triodes and drive the LED on or off. So reset signal. Transmit at the up and down two slots. From beginning to end on the entire hashboard, reset is a public signal. Clock signal. In top half board. As shown in the picture. Follow to this dotted line. Assumptive divide the hashboard into upper and lower two parts. In the top half, CLK generate by the crystal oscillator next to the first chip. Pass all the way to the last chip in the top half. No more transmit to down half board. CLK of the bottom half. Generate by the crystal. Besides the first chip of the bottom half, CLK send from first chip to last chip of bottom half. So the CLK is generated by top half and bottom half separately. RxD signal. RxD of top half from I/O port comes in. Then from the first chip sent to the last chip in the top half. It finished here. The TXD of top half generate from the last chip. Back to the first chip in reverse direction. Then from the first chip, send back to control board via I/O port. The bottom half, RxD and TXD are also independent. RxD coming in through the I/O port. By the up to voltage conversion, sent to the first chip. Then from the first chip, sent to the last chip. TXD signal. TXD in the bottom half, from the last chip. The reverse direction returns to the first chip of the bottom half. Then go back through the up to voltage conversion. Returns to the control panel. So these are the way of the signals on the hashboard. Only the reset signal is a public signal. Respective RxD, TXD are all separate into slots. Next, we view the half of the board for signals in and out. Pathways. As shown, the mark line has indicated the corresponding signal in and out. The first test point is the reset signal. Connect to a resistor. From this resistor, connect to the physis pin of first chip. This is RST from this pad. Connect to a resistor. From this resistor, connect to this resistor. From this resistor, send to the chip's 5th pin. This is UST. As shown. The second test point indicates the RxD signal. RxD signal through the wire connect to a resistor. From this resistor, connect to this resistor. Connect from here to the 4th pin of the chip. This one is RxD. RxD by wire. Connect to this resistor from the other pad. Follow this wire and connect to this resistor. From here, come to the 4th pin of the chip. This test point is the TXD signal. TXD signal. Over here is the voltage conversion chip. The voltage conversion chip requires a 1.8 volt and a 3 volt. 1.8 volts is from the first chip. This pin sends out through the big 0 ohm resistor. Send to this pin Liu of conversion chip. 3 volt is from the control panel. This test point. When the I/O cable connect to the I/O port, then the point will be a 3. Here's two filter capacitors at 3 volts. After being sent from this terminal, 3 volts as the temperature sensor power supply. At the same time sent to the pin 1. Of the voltage conversion. TXD after returning to the first chip. From the second pin out, connect to the convert chip by wiring to the pin 4 of conversion chip. So TXD convert from 1.8 VTV to 3. Send to the test point from I/O port. Return to control panel. So this is TXD connected to this pin. This pin is 1.8 volts. TXD come from the first chip. This is 1.8 volt power supply. From this pin of the first chip, send through the 0 ohm resistor. Send to up 3. The 3 volts is from this test point. From the control board, follow the wire from here. Both send to the temperature sensor and the voltage convert chip. And this test point is GND. belong to I/O port. The other 3 points. These 3 pads are for some data exchange, used to read temperature sensor data and EEPROM data. These 3 pads. This test point is the power supply of LDO. Only when executing FT redshipped instruction or executed power on instruction, there will be more than 3V power here, used to supply the front 8 or 9克 RUPS LDOS. Crystal oscillator generate the CLK signal from the 3rd pin of crystal to the 1st pin of the 1st chip. This is the 1st pin of the crystal. The 1st pin connect to the 4th pin as the 1.8V power supply. This 1.8V is also provided from the 1st chip through the 0 ohm resistor. The 2nd pin of crystal is GND. It connects to the 0 ohm resistor, conduct to the 3rd pin of the chip. That is also XCI signal of 1st chip. It's actually GND2. So these 4 signals in and out. The picture has clear mark. This is the top half. Hashboard. Signal in and out. As shown. After the signal enters from here, pass on in the board. The transmission on the top half hashboard, it's exactly the same as an air cooling hashboard. So there's no need to go into any more detail. We can refer to the repair manual of the air cooling frame machine hashboard. The bottom half hashboard. Signal in and out. Continue to do an introduction. Ahead we explained the reset signal is all through the entire board. So the reset signal in the bottom half is from above half board. Reset signal is from the last chip of above half board, from last chip out. That's the RST test point. After coming out, wire along the board side. Send to this resistor. At this resistor, after passing from this pad, pass to here. Send to the first chip of the bottom half board. Showed as the picture. Through this resistor, passing to the first chip's 5th pin from there. This is the reset signal. After reset signal into first chip, it passed from the first chip all the way to the last chip of bottom half board. And here is the last chip. From the last chip, right top first pin out, sent to the triodes. 2 triodes used to drive the LED on or off. A signal is returned the same time from the LED. Follow the wire to this test point. This is RST det. Back to I/O port. It is the last pin of the I/O socket. Reset signal. After entering the first chip, then from the first chip pass to the last chip. From the two triodes go out. The LED returns the signal from this pin to this test pad. From this test pad, this RST det signal returns to this pin of I/O port. That's the reset signal. In and out route. Coming from this place. Send to first chip through a resistor, all the way to the last chip. And from here, return signal to this pin. Return to control board. It's the reset signal entire route. Then CLK signal, also produced by the crystal oscillator left beside to the first chip. The 1.8 volt power required by the crystal, by the 0 ohm resistance to provide. The first pin connect to fourth pin of crystal as 1.8 volt input, and this is second pin. It's the GND. So this wire is actually connect to the copper sheet. So it's the GND. Third pin output CLK signal. RXD signal is also from I/O port. From this pin, coming and pass this test point RxDH1. Then come to voltage convert chip up to the pin 6, then output from above toward pin of up to. Send out towards the resistor, pass resistor to the fourth pin of the first chip. This is the RxD signal. It is needed to go through a voltage convert chip up to resend to first chip of the bottom half. TXD signal on the bottom half board. TXD. The TXD of bottom half board sent from the last chip. Reverse direction return to the first chip. Then from the first chip, also go through this voltage conversion up to return to the control board. So the RxD and TXD in bottom half board all need to go through this voltage conversion chip. So this up to is used for voltage conversion of both RxD and TXD signals. Voltage of up to is the same as the up 3. This voltage conversion chip requires two voltages supply. The first power is the bus pin. This bus pin voltage from the control panel. It's 3V old power from micro port. The first pin is to 5V. 5V is supplied by this LDO up 1. This LDO is the only one. Voltage output different LDO. Its output to 5V. The power supply of this LDO is the first and third pin connected together to this 0 ohm resistor, and then through this 0 ohm resistor to a 4.7 ohm resistor. The 4.7 ohm next to upwards. We can do a measurement. As shown in picture. This pin is to 5V, up to supplied by this LDO up 1. LDO is fifth pin, output the power to 5F. To first pin of the voltage conversion up to, then up 1. Its 1st and 3rd pin are connected to this 0 ohm resistor. This 0 ohm resistor by a wire connect to a 4.7 ohm resistor at above half hashboard. Voltage from a domain. Supply pin 1 and pin 3 of this LDO up 1 as input. Its power is sent from this location. Connect to the 4.7 ohm resistor. GND for the top 4 pins of up 1. You can see it's connect to the negative pole copper sheet. In first domain, if you measure the voltage of their above pins, this pin 4 can be used as the reference GND, the downside 4 pins of up to. The reference GND is pin 5. Pin 5 is I/O GND. It's coming from the control board. So if you want to measure the pin bar voltage or other 2 pins of the signal voltage, this reference GND point actually is through this 0 ohm resistance reached. To measure voltage or signal, need choose the right pin as the reference GND. So, this explained in the bottom half. 4 signals of the hashboard, in and out detail. Other circuit of the board. There's no difference with the air cooling hashboard. So repair procedure. Almost the same. In common, we need to first check the output of the LDO is normal or not. If the LDO output is abnormal, it could be in this chip's domain. A certain chip is unstable. Pull the voltage down on the LDO fifth pin, or the LDO itself. Possible defective. On the basis of making sure all LDOs are work normal, then we start check the reset signal first. Second CLK signal. Third RXD signal and fourth TXD signal. The repair procedure is the same as the air cooling hashboard. because the size of the hydro-cooling hashboard is large. So when you need to do a chip replacement, or while do soldering, we need to do a board warm-up first. Put the board on heating plate. Perform an even preheat. After evenly preheating, then focus to heat the specific area, the location where you need to replace the chip. If have not preheating, maybe due to board deformation too fast, causes the chip pad curl up from the PCB. Lead the hashboard to scrap. After repairing, do the assembly. We must guarantee all screws have not missed. If there is, screw forged to fix. May cause the hashboard and the cooling plate. Inadequate contact will cause some chips' temperatures to overheat. The server cannot run properly when it is in operation. This is the point that needs to be noted. And then when it was put back into the chassis, take area of the cooling plate joint. Joint of cooling plate is fragile. Avoid no to hit the chassis. Install need more patience.